So we've already done some solving right triangles, and we're just going to do some more of them now and apply the skills we've learned throughout this chapter. So again, remember that we learned about inverse trig ratios, and we use those when we're trying to find the measure of the angle versus the actual trig ratio. So this is just repeating that. So here, let's just try to draw and practice setting these up. Draw a diagram showing a person who is 1.5 meters tall. So here's our person, 1.5 meters tall, standing 20 meters away from the base of a building. So 20 meters away from the base of a building. Here's the building. Also show that the person sights the top of the building with an angle of elevation of 58 degrees. Find the height of the building. Now, this is a little bit interesting because it's telling you this person is 1.5 meters tall, and it's telling you that the person sights the top of the building with an angle of elevation at 58. So these are a little bit tricky because how these work is the angle of elevation can either come from the ground up and be here, 58 degrees, or the angle of elevation can actually come from the person's line of sight, which would be like that. When they tell you the person sights the top of the building and it doesn't say it's 58 degrees from the ground, what they're saying is that the 58 degrees is from, you draw this kind of like this horizontal line, and this is where the 58 degrees comes from. So this imaginary horizontal line is also 20 meters, okay? Now the difference is if you're trying to find the height of the building, right, it's going to be the opposite side of 58 is this h, let's say, but then you also have to add here another 1.5 meters for the height of the person. So we're going to use trig ratios to find h, or let's not even call it h, let's call it x. And we know that the height of the building is going to be whatever x is plus the 1.5 meters, which is your eye, the distance from the floor to your eyes, in essence. So again, now we know we've got the opposite side, and we have the adjacent side. So the ratio that I'm going to use is tangent. The tangent of 58 degrees is the opposite over the adjacent. And I make the opposite here x. So again, if I multiply both sides by 20, I know that 20 times the tangent of 58 is going to equal x. And when I do that math on my calculator, it's going to be 20 times 1.6003, and that's going to be 32 equals x. So the height of the building, or x, is 32, but that's not the whole height of the building, is it? Remember that I have to add the 1.5 meters for the person, and so I'm at 33.5 meters is the height of the actual building. So again, just be careful with those elevations. Is the elevation coming from your line of sight, or is it coming from the ground? Because that is going to be a little bit different answer each time. This problem is really strange because, again, if here's the sun, here's this horizontal line, and our angle of elevation here is 38 degrees. And so here's your building, right? So obviously it forms this right angle, but it talks about the shadow. And so the shadow would kind of go this way, which kind of drives me crazy here, but 45 meters. And so again, I would assume, that you could then draw this way, and the 38 would be here. So either way, I think the height of the building is this. So even though the shadow's on the other side, I think it's okay and safe to assume that it would look something like this. And so remember that if you have 38 degrees, you've got the opposite is what's the height, and the adjacent is this shadow. So we know that tangent uses opposite and adjacent. And so again, if I multiply both sides by that adjacent side, 45 times tangent of 38, I'm going to get the height, which is my opposite side here. And so again, I go to my calculator. The tangent of 38 is 0.7813. And when I multiply that by 45, I get a height of 35.2 is my height of the building. So 35.2 meters is how tall the building is. So solving a right triangle, again, we've talked about this in previous slides. It's about finding all the unknown side lengths and angle measures. And again, usually you're gonna have either two side lengths, and you're gonna have to find the third side length and the two acute angles, or you're gonna be given one side length and one acute angle, and you're gonna be asked to find all the others. So in this one, notice you're given one angle and one side length, and you're asked to solve the triangle. Well, again, notice that the triangle has angle A, angle B, and angle C. So angle C is always 90 degrees, angle A is 42, and you know that angles A plus B have to add up to 90, so you know that angle B is going to be 48 degrees. So this one was easy to solve for. Now we have to find the missing sides. So the missing sides are little a, side little b, and side little c, which obviously this is little c, this is little a, and this is little b. So side b is 70 feet long. We've got that. So now we have to use our trig ratios to find the rest. So I always use the values that are given there. I try not use my own values. So in other words, if they gave me side A as 42 and they gave me little b as 70, those are the numbers I'm going to utilize to find all my values. I don't want to use, let's say I found angle B is 48 degrees, but what if I did my math wrong? If I mess up on my math, then my measures are all going to be wrong. So I try to use what's given to me. So when I'm determining my trig ratios, I'm going to go with, again here, I'm given angle A, and I'm looking for, let's say, little a, that's opposite, and the 70 is the adjacent. I know my hypotenuse is over there. So I know that the ratio that I'm going to work with here is tangent. So tangent of 42 is going to equal opposite over adjacent. And if I multiply both sides by 70, I'm going to get what side little a equals, right? So 70 times the tangent of 42. Tangent of 42 is 0.9004. And when I multiply that by 70, I get 63.03 equals A. It tells me the nearest tenth, so 63.0 equals A. So it's 63 units long. So A is 63. And again, I do have that now, and I can utilize that, let's say, to help me find little c, which is the hypotenuse. However, I'm going to keep from doing that. What I'm going to do is I'm going to use the other values that were given to me. I'm going to try to find the hypotenuse by using, again, 42 degrees and 70. So I know this is adjacent and this is hypotenuse. So I'm going to use cosine. So cosine of 42 degrees equals the adjacent side over the hypotenuse. And again, I'm just going to solve for the missing values. So side C times the cosine of 42 equals 70. And if I divide both by the cosine of 42, then I'm going to be able to get the length of side C. So side C equals 70 divided by, and the cosine of 42 equals 0.7431. So I'm going to do 70 divided by cosine of 42. And I get 94.2. So I know that my hypotenuse is 94.2 units. And so there's I solved my triangle. I know it's 48 degrees. So I come back over to here. Side A was 63 feet, and side C was 94.2, and but now I have all my measures, and that's what's called solving the triangle. So we keep going to more problems, and again, this is just different ways you're going to see it. Same skill every single time. So it says, suppose your school is building a raked stage. The stage will be 30 meters long from front to back. So the stage, now thank God they give you the drawing, the 30 meters is starting at the front, here's the back, and it's the angled height there, or the angled strip. Then it says with a total rise of 2 feet. So again, 2 feet is how high it's over here. So the horizontal length is what we're missing. A rake angle of elevation 5 degrees or less is generally preferred for the safety and comfort of the actors. Is the rake stage you're building within the range suggested? So basically we're trying to figure out, is X 5 degrees or less? Well, let's figure out what X is, and then we'll answer the question. Again, if X is here, we've got the opposite side and we have the hypotenuse. So the sine of X is going to equal the opposite over the hypotenuse. And when I do the division there, 2 divided by 30, I get the sine is 0.06667. And so if I want to know what the degree is now, I'm just going to find the inverse of the sine, and I'm going to use, the inverse, right? And I'm going to get that X equals 3.8 degrees. So since X is 3.8, yes, it's less than 5. So it is within the suggested range. So again, since I was looking for angle measure, I used inverse sine. And that's it. So these are just a bunch of problems that they give you different ways to apply the same strategy that we've already discussed multiple times.